interviewer that's week. So if Paul wants you, you can do it.
What do you mean
This
next week?
And now, I mean now. I did last week, the interviewer last week in your absence. So
I see. Thank you. Yes, I can. And actually, I had a question right off the pop.
Okay. Let me. Right. Starting the closed captioning. Okay. Yeah. I think we're ready to start.
Actually, two questions. First, just a notational question: is that notation for the whole preference structure a lowercase j, or is it uppercase j dot?
That's a good question. I guess I was indecisive. It is what it is. We can call it an uppercase J. It probably makes more sense than a lowercase j, but maybe we should ignore the dot.
I mean, my instinct would just be to do Blackboard bold or something.
Yeah, that makes sense. But I used Blackboard bold later on to distinguish the logical inductor version.
Yeah, I'm not sure then. I'd need to think more about
I guess it would be
what I want to write down for that.
Yeah. So it's like,
so maybe script J?
It is supposed to be the same type as over here, really. It's just like this one is time indexed and this one is just like one. So maybe it should both be Blackboard bold.
Okay. Adapted to
So
maybe. The second question I had, just to check for the second point there about P of E, that should imply finite additivity, right?
Right, yeah. The second one is finite additivity. We can get like from combining two things, we can combine as many finite things as we like.
Yeah. And then finally, we're motivating not defining, or we're motivating a V of bottom not being defined because that's meant to be something that can't happen.
Yeah.
Okay. I'm still taking assertive notes on.
Yeah, so something that can't happen here can't have an expectation.
So I'm not familiar with the Jeffrey Walker proof, but by motivating, do you mean that we can give it a rational justification, or what is the case, or is a free parameter in that like we could make it work either way?
The former, I think.
Yeah, yeah. It's like Jeffrey Walker's framework. This is part of the framework. And the motivation for that is like, well, we can't take the expectation of the empty set.
Oh, I was going to ask the other. Actually, I think I should have asked about this before. There should be a. Sorry, words. So the other thing is those two axioms for probability would seem to imply that P of not A equals 1 minus P of A.
Yep.
Okay, so we do get to assume excluded middle.
Yep.
Okay.
Yep.
Then yeah, that'd also be why. So consider that in that case, P of bottom is 0. So P of bottom or bottom is also 0. So no matter what you want to plug in for your artificial V of bottom, that's still going to be something over 0.
Yeah.
Which is not good.
Exactly. So just to give everybody a little reminder of where we are, like, so the reason we're doing this is because I want something that's like logical induction and like propositionally coherent logical induction, but also has this additional coherence constraint that I'm using to like decompose branches of possibility for updateless decision theory. And so I'm outlining this as like kind of an extension of propositional coherence. This part is like propositional coherence for probability distributions. And then this part is like our added like expectation coherence constraint. Yeah. And then we're going to put this together into a logical inductor-like thing. So a trading strategy or high-level belief has the type from of some kind of continuous function from J to J. So if we want to make a computable version of this, this is going to have to be like some library of function calls, so to speak, that lets us put together continuous functions rather than just having arbitrary continuous functions. Much like traders in the logical induction paper, or rather trading strategies in the logical induction paper. And then notice that we can define weighted mixtures. So like, we call this like a high level belief because it's opinionated. It takes, we can think of it as taking probability distributions, or rather Jeffrey Bulker preference structures, and then correcting them somehow. But it can have opinions only on isolated propositions.
Isn't it though?
Sorry, yeah, I intend J as a type. Like J is a P together with a V, or equivalently a finitely additive vector valued measure. Like, oh yeah, this is, yeah, J is, yeah, I intend J as the type of finitely additive vector valued measures. But I guess I'm using it, yeah, sorry, apologies. I'm using it as both the type and the instance. Bad notation.
Oh.
Yeah, so we can define these high-level belief thingies, which have opinions on some propositions and not others because they like correct some things and not others. We can make weighted mixtures of these things by kind of the obvious definition. And we can collapse one of these things by taking a fixed point. So
why do we know we have any of these?
Because of the continuity. That's not really saying enough. So like,
do we know that J dot is compact as a type?
Yeah, that's a good question. I think
that'd be necessary for continuity to be sufficient.
Well, in any case, I can require it to be compact, I think. But yeah, this is an important question which I haven't done my homework on.
So it has so H has a unique fixed point?
Not unique.
Yeah, that's the other part. I am not clear that there is precisely one of those, and if there isn't precisely one of those, numerous question marks about whether that's something we can do meaningfully.
I'm not intending for there to be precisely one of those. This is like analogy to logical induction, right? So like the logical induction market has, in general, many fixed points.
Okay.
So when it's like taking the equilibrium of a game. Like when we collapse it, we have to make a choice of how we collapse it.
Shouldn't our weighted mixtures be specifically convex combinations? Or I don't know that that's like if we don't do that, that seems like you could have thing. Oh no, I see. Never mind. Sorry, weighted mixtures. They don't need to be convex combinations because we're not plugging anything in after we multiply.
Sorry, what do you mean by convex combinations?
Something of the form AH1 of x plus 1 minus AH2 of x. Like specifically
The
here is something between the
Oh
two.
yeah. Sorry, yes, I intended that as well. I agree with that.
I mean, you can scale them all like that, but I'm not actually convinced that it's necessary.
Yeah, you make a good point, but
Or actually, hold on, is it necessary? Because if we're going to, I think if you don't require it, you're not guaranteed to have H3 be an actual trading strategy.
right.
Right.
Why not?
Let your A and B both be larger than 1.
Yeah, but why will H3 then not be necessarily a trading strategy?
So I am intending trading strategies to take J to J.
Right.
And so we we want like P of top to be 1.
Right.
And we might get like P of top as 2. But yeah, don't J stop making sense as prob utilities if they escape the positive quadrant. So I think they can at least be in just the
Upper half plane.
Yeah, they can be in a half plane because it's fine if we have some negative slopes, negative expected utilities. They do need to stay within a half plane. Otherwise, otherwise we have like vectors that can add up to 0, like the 0 vector, even though they themselves aren't the 0 vector.
I mean, yeah, but if you are doing linear combinations in the right plane, then you are also going to get something in the right plane as long as your coefficients are positive or like non-negative.
Yeah. So it could be any half plane that we keep to.
If I'm understanding this correctly, that the first coordinate is a probability, then it's not a half plane, but like like line.
Yeah. I mean, yeah, that. But I think like having the probabilities sum to 1 is not like so important to the math. If we allow the probabilities to sum to some other number, then it's just like a probability distribution that hasn't been normalized, but everything else still works fine. So yeah, we need, in fact, we need to constrain to something like that. But the upper bound could be flexible.
And that was why I was talking about, that was why I was saying that we could rescale it to be convex if we didn't start with 1. We would just need to divide through by A plus B. And then we would in fact have something of the form A1 minus A. Because you got, I don't know, 2/5 and 3/5 now.
And so Vladimir Nesov says, right, half plane is okay, but I'm being wary of the linear combinations, so the coefficients are positive. Yeah, that was my attention. Sorry, I was I was pretty hasty here with how I wrote down everything. And indeed, that represents the very preliminary state of this idea.
I'm actually not convinced that they strictly need to be positive as long as they're convex. You could totally have -1/2 and 3/2. It'd be weird, but I think you could still do it. I don't know how relevant that is, though. Probably for the most part, you would want to just stick between strictly 0 and 1.
I mean, you could have, so like if you had -1/2 and 3/2, then you could have an event where where H1 assigns like positive, where H1 maps it to a positive probability and H2 maps it to 0 probability, and then you would get a negative probability from H3.
Maybe, but then in that case, you should expect something very weird to be true of that event, given that one of these trading strategies assigns 0 probability and the other one assigns non-zero.
Well, so
but I can see how this still happens. Sorry, go ahead.
So change it to something else, like probability of 0.9 and probability of 0.1.
Yeah, I can see how this might still that might still pose a problem if you do something like that. If you like have very small probability for one and large for the other, that has the negative weight. So maybe not. Maybe not. Code constraints. So when you say, what do you mean by softly violate incompatible constraints?
Okay, so what it means for one of these things to encode a constraint is that when some j satisfies that constraint, then it just maps it to itself. And then when something violates that constraint, then it's like somehow taking it towards satisfying that constraint, right? The only thing that's required is that it makes it not a fixed point. And then we think of the constraint as like the set of fixed points. And then if we combine two different of these high-level beliefs, if we take a weighted mixture of two different of these high-level beliefs that where the weights are positive and sum to 1, then we're like averaging the different ways that they enforce their constraints, right? And so if the two constraints are compatible, then fixed points are just going to be or at least, yeah, some fixed points are going to be just the points that satisfy both constraints. And then if they're incompatible, and if we satisfy the conditions of Brouwer's axioms, or sorry, Brouwer's fixed point theorem, then there's going to be some fixed point still, right? And so if we imagine something like we're combining one high-level belief that thinks that things should, like a certain proposition should have probability 0.5, and it is like dragging everything towards 0.5. And then we have another one that thinks that the same proposition should have probability 0.4, and it's dragging everything towards 0.4. Then the resulting combination is still going to rule out anything that's above 0.5 and below 0.4 because it's just combining things that are like dragging things in that direction. But then it's going to have a fixed point somewhere between 0.5 and 0.4. So that's what I mean by softly combining constraints.
Do we know for a fact it's going to have that fixed point between 0.4 and 0.5? And I mean, I'm still thinking about, I'm not necessarily convinced that even if we do have fixed points for H1 and H2, that the fixed points of H3 necessarily have to have anything to do with those fixed points if they aren't exactly the same fixed points.
Yeah, I mean the fixed points of H3 will include the intersection of the fixed points of H1 and H2, right? Because
but I'm thinking about the case where they don't where the overlap or where the intersection is empty.
yeah,
As it might often be.
yeah. So where the intersection is empty, I'm not trying to make some strong claim that it's like always like between the two or something. I'm just saying, well, in a simple case where
Both of these have
H1
fixed points all over the place and
like
overlap in this band, then the fixed points of the mixture will be most of the stuff in the overlap band, right?
yeah, it's like it will depend on the details of H1 and H2 a lot. Like, so it does not just depend on what the compatible. Sorry, it doesn't just depend on the constraints that H1 and 2 are enforcing. It depends on the details of how they're enforcing those constraints.
Yeah,
But
I'm
in simple cases where they're just kind of taking things towards the constraints, then it'll be like some kind of compromise.
Maybe this would be helpful. Like I vaguely remember that there are one or two concrete examples of H1 and H2 that were like quite illuminating to me when I read the post, your post, fixed DT.
Mm-hmm.
Yeah, so for people interested, maybe helpful to check that out. I forgot the examples. It's too long ago.
Okay.
Oh, another thing, is this meant to be the I guess tightest specification of all high level beliefs of all trading strategies? That they're some continuous function from J to J?
I'm not sure quite if this is answering your question, but like the relationship between this and trading strategies in the logical induction sense is like, for one thing, we're giving like trading strategies in logical induction, you map probabilities to trades, which are not probabilities, right? And here we're mapping probabilities to probabilities.
Yes.
And
That indeed does not answer my question. Let me try and rephrase it.
Okay.
Let's say I take an arbitrary continuous function from J to J. Do we know that that's a trading strategy, or is there something more that has to be true of it?
Oh, okay. So I think in the case where we want computability, certainly we have to put more constraints on it. And then also, like you mentioned, with I intend to satisfy the conditions of Brouwer's fixed point theorem here, and I'm not doing the work to make sure that I've done that. And so generally, yeah, I think there's...
Isn't it just continuous function on compact domain?
Yeah.
I don't think anything about the function itself would be what you care about for Brouwer's fixed point as long as it's continuous.
But
it's literally any continuous function on. Go ahead.
But we might need to like restrict the domain to make sure it's compact, right?
Maybe. J as a space isn't totally obvious. That needs to be clarified to make sure fixed points are there. Sort of. Not really.
Yeah, it might be the case that these things are automatically compact.
I guess, yeah, because because continuity requires that you have some sense of open sets. Yeah. So I'm still taking notes on all of this. Still want computability, so this should be finitely specified with simple default behavior for E not mentioned. Right. So not just some, it maps events to values, so not just some space of functions. I think at least.
Oh yeah, yeah. So this is like we have a finite number of small sentences that the market actually trades on, and then infinitely many sentences we have some default behavior like setting them to 1/2. You were saying?
Oh, I think I understand. I think I'm pretty comfortable with what's going on here. How about everyone else? Do other people have questions about the setup?
All right.
I guess I'm still a little iffy on softly violate incompatible constraints. Or
Yeah.
how it is how are we encoding constraints?
Constraints are just when we regard a trading strategy as a constraint, we're looking at the set of fixed points that it has, and we're thinking of it as like trying to enforce those fixed points.
Got it.
Which might not be the best way of understanding what all trading strategies are doing, but is certainly a good way of understanding what some of them are doing.
So it's possible that we don't care. It's possible then that our space J isn't compact, and that we care about any continuous function from J dot to J dot. And also, it turns out that having a fixed point is a decently special property that tells us this trading strategy is one of those kinds that has some constraints at all.
I think I need, because I'm doing a logical induction like thing, the fixed point property is pretty important. But yeah, I see what you're saying in general.
Yeah. I mean, I think it'll be a desirable property, but not one that you get for free.
Yeah.
But
okay.
It'll be a desirable property, but not one you get to free, but one that you can relatively freely pass to.
Like in probability space, like in normal logical induction, where we're just taking a fixed point on these prices that are like probabilities, if you keep trying to pump up a probability, then 1 is your fixed point. Whereas here, because we also have our utilities, the Jeffrey Bulker framework actually, I think, implies that the utilities are bounded on at least one side, but it can be unbounded on the other side.
Does it need to be bounded on one side?
I think so. It's like it has to be restricted to a half plane in the vector picture, in the sense of the thing that's a complement of another half plane. So it has to be closed on one side and open on the other, and we restrict to that, so that we don't have anything that's like the exact reflection of itself around the origin.
Huh.
Because we need the slope of every vector to be well defined, so we can't have two mutually exclusive things that we can combine to get to zero vector. But so it can be unbounded in, or yeah, wait, what am I saying? Well, yeah, in any case, it can handle unbounded utilities. like unbounded expectations, so long as the probability of those things shrinks. And so you can have these high-level beliefs that are just like pushing the expected utility up and up and up. But then because the probability of those events are required to shrink, then it's like you still have like some kind of fixed point. But that fixed point could be itself the zero vector, which could be a problem.
By expected utility here, do you mean V or P times V?
PV, right?
But wasn't V supposed to be like...
Oh, right.
By expected utility, I mean V.
Okay.
Maybe I should just say expectation or value. What I was trying to say is that you don't need to have fixed points in V. You can have a fixed point just like the vector space overall, so that your like fixed points have values of the P and the P times V. But I suppose that now I'm thinking that could cause a problem, because your fixed point could be the zero vector. I think you don't want that. Yeah, so maybe this whole framework is problematic. I'm not sure. But should I move on slides?
Sure.
Can I take try to take another perspective to understand?
Yeah.
I don't think I fully understand high level beliefs. So
Yeah.
The map from those measures to measures, does it have is it like defined with a specific conceptual meaning in mind, like what it means for a certain measure to map to a measure?
It's like, so if we personify the traders and think of their trading strategies as rational, then it's like, I see that the market believes this. Upon seeing that, what I believe is this. So it's like what I believe on
the domain stands for the market belief. Domain, the measures in the domain is market, and the measures in the domain is the traders belief, actual
yeah. So it's something like I see market believes something, then I apply H to it, and then I give my own beliefs. So it's kind of like beliefs parameterized by the state of the market, and they are behaviorally implemented by by how I'm buying and selling stocks.
Yeah.
Okay.
Okay, I have another question to ask, but I think I'll ask it on the next slide. Yeah. Yeah.
Okay.
Thanks.
So, yeah, as in logical induction, the trader emits a sequence of these trading strategies. These are the same type as the H. And it has some initial weight, which we call its initial wealth. And then we imagine that the traders Kelly bet on the stocks V and P. So it's like there's a market good for the probability, and then also a market good for the value. And the traders are expressing beliefs and then Kelly betting based on those beliefs. And then the stock prices, which I'm representing by the bold V and P, are given by fixed points of the mixture high level belief that mixes together all of the trading strategies according to the weight of that trader on that day. And we compute the weight of the trader on the day according to the value of the investments that the trader made on the previous day as evaluated on that day. And so that means that the trader weights depend on the fixed point that we find on this certain day. So, of course, the fixed point depends on the trader weights on that day. So the weights have to be computed as part of the fixed point.
Is that superscript a 0 then?
This is D.
Initial weight.
So like oh yeah, this is 0.
Superscript line 2. Okay.
Yeah, like this is the
Is there a
trader
reason we
number.
don't just have that be? Is there a reason not to just have that as a function?
Sorry, what? Oh, like
WI. Just say like
WI
trader's wealth.
and
The trader
in brackets.
TI. Yeah. Has
yeah.
wealth WI of D.
No, yeah.
I guess maybe not fixed based on what you see.
Yeah, that could be.
Yeah, no, that might. I think it's going to be dependent on what you actually see and what other traders actually exist. So maybe not.
Right. It's
Not
not
happy
like
with something that looks like an exponent.
It's not some fixed function. Yeah, it's a function that we need to
That'd just be the point at which I use doubled subscripts. That's fine.
That's fair. Yeah. And so then we can think of the P.
Just mean,
oh. Did you say something?
I said it just mean nitpicking notation. I have a strong sense of aesthetics with respect to notation.
Yeah, that's fair. So then, yeah, P acts like a prediction market, whereas V is kind of like an impact market. Not in the details of how it works, but like this is like we're buying the event. So if I think, oh, that event is more valuable than the market says, then I'll buy a share in that event, and then if that valuation goes up later, given the whole market dynamic, then I might later sell that in order to make money.
Of course. So question, I don't think I quite understand your question, Vladimir. Could you try and explain a little bit better what you want to ask about? We have, why do we keep a V in addition to P instead of only components of J that are things of the same kind?
I think it's probably because like we want this to be like the high level belief to implement both like kind of actions, like how we update our utility estimates and not just probabilities. Something about value updates.
Components of data are things of the same kind. I'm not sure this is what this is asking, but it sounds sort of like asking, why aren't we keeping track of probabilities and utilities instead of probabilities and expected utilities? Is that like the question? I mean, probabilities and utilities still aren't things of the same kind. I'm not sure what things of the same kind means.
I think Vladimir is asking, why are we keeping track of V in addition to P rather than just P?
So that's because I'm trying to enforce this property that has to do with the expected values as well as the probabilities.
Oh. Okay.
So I'm trying to make something that generalizes the concept of propositional coherence to also give like some expected value coherence. It's oh.
Yeah.
Okay. I see. Yeah. Yeah, that's just kind of like a choice of basis question. So yeah, we Scott calls these P times V things the shouldness. So we could just track the probability and the shouldness instead of the probability and the expected value. Oh, okay. Oh yeah, right. Okay, so yeah. But this is basically like, you could say like a matter of like how humans think of it or a tradition or something. It's not like critical that I am talking in terms of P and V instead of talking in terms of P and P times V. So yeah, you could say it's a matter of like, well, V closer corresponds to things that we normally talk about in expected utility theory or something like that. But we could talk about things in the other way.
What's the distinction between the double line letters and the stock like the naked V and P?
Yeah, so I was using the double line to indicate the ones that obey the analog of the logical induction criterion for this setting. But I don't like stand by that choice of notation. Maybe I should have made all of them double line or done something else.
So in other words, double lines are fixed points, and non-double lines are like general.
Yeah.
Okay.
Yeah, that's one way of thinking of it.
So, what is the actual effect of like the second point? Imagining traders clearly betting on.
Yeah.
If eventually we only consider fixed points, then is it true that the other parts of the belief function are not used or not relevant?
The other parts of the belief function still help determine what was or was not a fixed point, right? So if like we take the fixed points and then we say, well, but what if the other part was this way instead of that way? Like it could have created a different fixed point that we could have taken if we change those other parts. So in some sense, it's relevant.
I'm imagining like a process by which you could reach the fixed point. I've again, I vaguely remember that this is also discussed in the post, fixed DT post.
Mhm.
So what I like, my intuition is that the other points, like there, if there were some process for trial and error, by which like the market could see what the traders are, what's the difference between the the original market prices and the traders prices, and eventually converge to the fixed point. I'm just saying that this, why this is not present. Is it like not needed?
I mean, so first off, this is definitely like a hasty, like, I did not take the time to formally spell out everything as one should. I'm trying to present like a research direction. And so I didn't fully spell out things like what it means exactly that we imagine the Kelly betters. We imagine the traders as Kelly betters. Like, what's the actual formula for how they make trades based on that? But second of all, I mean, from the perspective of logical induction, it doesn't matter too much how we find this fixed point, right? Like the logical induction criterion doesn't really care. We just have to be able to find an approximate fixed point, and otherwise it's fine. Now, if we take like fixed DT into account, then like, yes, it matters like which fixed point we select. I don't know. Does that like does that answer your question? Or
I don't think I understand, like fully understand what logical. I think I noticed that like the problem seems to be I'm not understanding the aim. Like, what does logical induction adapted to JB actually mean?
Can I try and answer that? I think I understand.
sure.
Okay, thank you.
So remember how with our ordinary logical induction, all we cared about was probabilities, basically. Our prices reflected how likely do our traders think that some given proposition phi is to be true. And that was the only thing that determined prices. But
Yes.
now they're going to bet on both of these things, on both how likely is it that this thing happens and how overall weighty is it for this thing to happen? How good is the overall outcome of this thing happening? And maybe the probability is very small of it happening, but maybe the probability is very small of it happening, and the expected payoff if it happens is pretty reasonable, such that the overall weight is pretty small. Or maybe if it does happen, it's a really large utility such that the overall weight is comparable to something with more normal utility if it happens, and a much larger probability of actually happening. And there are now these two different flavors of proposition, I guess, that our traders can bet on. And on the one hand, we know that our P of X always have to have prices between 0 and 1, but our V of X can have prices all over the place.
And
Does V have a ground truth like P?
so
or am I misunderstanding?
P doesn't have a ground truth necessarily, right?
It,
So yes, like P, As in,
So it's
no.
like J has a ground truth, and that ground truth is expressed by P and V.
Sorry, what do you mean by ground truth?
Like in the logical, so yeah, like originally in the logical induction framework, where like that paper proves these properties of like the probabilities for statements eventually converging to what
Okay.
they actually are. So in adapting, I'm thinking like the aim is that sense of the goal still exists here?
Sorry, they converge to something. What does it mean for them to converge to what they actually are?
I think that Norman means that like we can prove some statements, and provable statements will converge to 1, disprovable sentence will converge to 0, and like
Yeah.
what would what should converge the V's, what should V's converge to?
Right. Okay. So yeah, I feel like from my perspective, yeah, objective morality, obviously. Yeah. I agree with this statement. But like from my perspective, the good version of this question is like, well, the logical induction paper proves a number of desirable properties about these probabilities. What are like the list of desirable properties that we might want to prove about these expectation-like thingies? And I think like this is a good question that like I don't like have all the answers to. I might have some good guesses if I thought about it, but it feels like Norman is asking like an objectified version of this question, where it's like no, there's like a ground truth, there's like something it converges to, and it converges to the right thing. And Norman is saying something like, I understand what it means to converge to the right thing in the case of probabilities, but what does it mean to converge to the right thing in the case of expected values?
I have a question in a similar vein. Can we assume that the traders know the utility function?
We can, but we don't have to. Like, or actually, like, maybe I should put it a different way. Like, so in the pure, like, classical logical induction case, what if I said to you, can we assume that the traders know the probability function? Like, this is kind of a weird question, right?
Okay, so the traders aren't necessarily super certain of how good the thing is if it happens either.
Like, to elaborate on that, like, what is it like? Can the traders know the probability function? It's like, well, the traders can have access to the mathematical formulation of the market itself. And so if we think of the limit of the beliefs as the market approaches infinity as an objectively correct probability function in some sense on the universe, then like the traders can know this abstract mathematical formulation of like, yeah, we can take the limit of our beliefs. This is like humans saying, like in the pragmatist view on human rationality, the truth is defined as the limit of scientific inquiry. And so it's like humans are saying in this pragmatist school, what is the truth? Well, the truth is the limit of good thinking. We take good thinking to this extreme limit, and that's what the truth is. And so in that sense, yes, it does provide some kind of objective ground truth. But the objective ground truth is kind of being defined with respect to what we think. And so in that way, it's kind of not an objective ground truth. It's just, it's what we think. It's like the best we can do in some sense. And also this object, like what is the limit of the logical inductor, is not something that the logical inductors as a computable logical inductor market can know, even in the limit, right? Like even in the limit, they don't become confident about what the limit is because there's some mathematical undecidability there.
Right.
And so in a sense, we could also say, no, they can't know. And I think that the utility case is analogous.
Okay, that makes sense. That had been my question of, are they assumed to know, or can they not know, or is it something where in principle they could know, but in reality probably we should model them as not knowing and being slightly uncertain forever about what the actual payoffs are?
Yeah, I think we could imagine that we stipulate some mathematical utility function. Maybe this is a dissonant.
But then this just collapses. Yeah, then it just collapses to
But
more ordinary logical induction, because then your E of X are
I don't think we should imagine that, because it's not like a realistic model of humans or something. Like part of the interesting thing about this is to model these really rich values that aren't just some mathematical utility function. Again, we could extrapolate. We can take the limit and then take these expected values and the probability and be like, okay, what utility function would justify these expected values? It's not like I can strongly say the utility function doesn't exist, but it's kind of like an indirect description of what's going on.
Mm-hmm. Okay, I think I'm finally happy with this slide.
Okay, cool.
I feel like there's I understand your perspective now, but maybe there is the difference mainly comes from, like, I get the strong impression from reading the logical induction paper that the absolute thing, like everything they are doing are relative to the deductive process, which is which is like what you can prove. So you have an absolute notion of proof.
Yeah.
For
this is what I first thought you might mean by ground truth, but then your answer made me think not.
Sorry. Well, I don't know what I said. That okay.
Yeah, I mean that's okay. Because you said that like the probabilities converge to the truth, which made me think you meant like also like the probability of undecidable propositions, which never get feedback from the deductive process, converge to the true value in some sense, which is a different kind of, which is like the pragmatist definition of truth that I mentioned earlier.
Mm-hmm.
But like the deductive process, this is like ground truth as feedback that we get, as opposed to ground truth as like some kind of limit of reason.
Why do we know there's finitely many of these traders? And or finite amounts of, I mean, there should definitely, actually, well, I guess a combination of why do we know that there's finitely many traders, and do we now have problems with,
I think can I like address Norman first?
Sorry, go ahead.
So yeah, like I think I'm seeing the problem as like it's easy to see what a kind of deductive process should be for the epistemic case. We maybe like observe things as being true, maybe we prove things as being true, and so they come into the deductive process and we get this feedback that way. It's harder to see what would constitute an observation for the expected value of something. And yeah, I agree, and I haven't like worked out what the kind of what a reasonable way of doing things would be. I think there's like lots of ways that you could do it. It's not clear exactly how you should do it, but broadly what I'm imagining, because I'm imagining like an AI architecture based on this, that it's humans are providing evidence to the system about what is of value, right? And so it could be like something similar to reinforcement learning somehow is like kind of the picture, or like humans are like looking at the evaluations that the system has on like various propositions and being like, oh, that seems wrong, and putting in some evidence to say, no, that should be valued higher or valued lower. That's the kind of thing that I imagine.
So I know maybe you haven't decided yet, but if we were to make this explicit, should the deductive process be replaced by some value generating process that satisfies certain coherence properties, and this construction, like logical induction adapted to JB, be defined relative to that? Do you think that's a good way
I
to
think
do?
something like that, yeah.
Mhm.
Yeah, like you could imagine it's like maybe instead of where the deductive process goes to 0 or 1, maybe this process is like narrowing down the expected utilities instead of just like, bam, this is the actual expected utility. I don't know how those details should work out, but something along those lines.
But an alternative would be to like to define. I'm just I just thought of this like a minute ago, so it's very rough. Like two intertwining process that stand on like sort of like equal footing, but one is like adapting to the other. Because like humans also have value uncertainty, so maybe the value generating process couldn't be as ideal as the deductive process.
Yeah, that makes a lot of sense to me, and that's yeah, I think that's ultimately what we need. In some sense, also for the epistemic side, like the setup where the deductive process just becomes like completely certain of things is artificial. Really, we have some uncertainty even about like the Peano axioms. So we're technically trying to be like very faithful to human preferences, including both human values and human uncertainty. Then in order to be sensitive to that, we need to give this kind of partial feedback for everything that does maintain some uncertainty. And yeah, I don't know mathematically what that looks like, particularly like taking the logical induction criterion and replacing the deductive process, which is a parameter in the criterion, with something that is itself uncertain and could even be somewhat money pumpable, because humans could like change our mind in ways that the market can make money on us. Like what that would look like mathematically, I haven't worked that out. But yeah, that seems like an interesting direction.
There's no grounding of P on non-tautologies either. What you deductively prove is that an event is a tautology, so P and PV are grounded to the same extent as each other. It's only V that introduces additional confusion or serves as a clue about hidden confusion that was already there about P. I'm just making sure to read this because I don't know if the chat makes it into the recording.
Yeah, thanks.
I actually do still have a question
Oh,
then.
do you want to ask your original question? I
Yeah,
think
right.
like yeah. Sorry for the yeah.
No problem. Very much so. I'm worried now. I was initially going to say that I really like this idea of let's look at this whole market as one agglomerated trader as weighted by wealth. But now I'm a little worried about the two different cases of, oh no, what if infinite wealth, such that this is no longer meaningful because this would need to be normalized by wealth. Like we would need to add up by sum of wealth just directly.
Yep.
Thing one is, why do we know that there are finitely many traders? And then thing two is, how are we planning to deal with the sort of observation formalism of an observation is a trader with infinite wealth?
Great, yeah. So thing one, I'm imagining this very much like in logical induction, you actually bring in traders by some schedule so that at finite time there's finite traders, but the list of traders is unbounded. And so you're always like reserving some money that you've set aside, like from these initial wealths. They don't, maybe we think of them as like not quite summing to one, and we've set aside some reserve, and we're always like giving them their initial allowance out of that reserve.
Okay, so it's like it's on day D, the sum over all wealths of non-observation traders is 1 minus 2 to the negative D. Something like that.
Yeah.
Okay, that I'm less worried about that first point then. But then the second point, I'm still iffy on.
Yeah, I am also still iffy on the second point.
Because I can see that the trading strategy would just be a very, very narrow one. But now you have infinity times 0 in a bunch of places, and that's probably not great.
Yeah, I feel like there's some mathematical theory to be worked out here. Why is it fine that the deductive process can have infinite wealth, even though it's critical that the market keeps finite wealth or keeps fixed total wealth, in fact? I think it is fine, but I'm working on the details. And particularly when we're trying to generalize from the type of deductive process in the logical induction paper to this like more exotic thing, then when does it stop being fine? When does it have the potential to cause trouble? To me, this is an interesting research question, along with some other questions that we've raised here.
I mean, my snap approach would be something like drop the idea of observation as infinitely wealthy trader and just have the advancing ledger of values of P of X and V of X, which are in fact known for sure that all traders have access to. This is like, it turns out that after this many days have passed, an event occurs, and now P of X is generally either 0 or 1, and V of X is either V of X is either 0 or U of X, like divided out. Actually, does that need to be the case? Yeah. Is V of X specifically expected utility, or is it expected utility assuming this thing happens at all?
Wait, what's the difference? Like,
one of them, I mean, counterfactual. Go ahead.
Right, like X could turn out to be bottom.
Yeah.
Yeah.
Like, not necessarily propositionally bottom, but it's this thing that now we've made some other observation, and
but maybe like PA bottom.
X and phi is bottom.
Yeah, that could cause a real problem here. I'm not sure what to do in that case.
It's possible that at that point you just say, actually, these should also have undefined value, but then how do you get payoffs there?
Right. Yeah. What do you do with all the wealth that's tied up in that?
Like, yes, we bet a bunch on like how good this thing would be under the assumption that it might happen at all. mean, you could just do the prediction markety thing and go refund all your bets on it no matter when you bought them. But I don't know if that's
Right.
if something else breaks because of that.
All right. So yeah, these are interesting questions. Maybe it's time to move on.
Yeah, sounds good. But I mean, everyone else
No.
has
Okay,
left.
and everyone else is left, and also this is like kind of starting a new thing.
Yeah.
So yeah, maybe we'd better finish here.
All right.
So
Sounds good to me.
as a reminder to those who are left, and I'll also post this in the channel, there is not going to be one of these meetings next week. And also we have an extra meeting later today that is Alex Appel, aka Diffractor, presenting on some research of his that's very much along similar lines to what we're going for here, although not exactly the same in details. But he has a some kind of logically uncertain version of UDT, which he says actually has a tiling proof, which is pretty exciting. So,
Right.
yep, I'll see you all around.
See you shortly.